Okay guys, I'm going to try and do a crash review of stoichiometry with you. So we have taught this, we did this before spring break, and you know, this is 2020, COVID-19, we're virtual learning now. So what we're going to need for stoichiometry, you always have to have a balanced chemical equation. You're almost always going to need a periodic table to look up molar masses to help with those conversions, and our molar map here on the back of our periodic table to help us move through from one substance to another in a chemical equation. So that's the difference between molar conversions, which we did in chapter 10, and stoichiometry, is we're changing from one substance to another in stoichiometry, and we're going to do a mole ratio in order to make that change. As a recap, mole ratios are found in the balanced chemical equation, which is why you have to have one of those, okay? So here, there are 4 moles of iron 4 sulfide, I'm not sure, iron sulfide, for every 11 moles of oxygen in the reaction. And when those react in that ratio, they're going to create 2 moles of iron oxide to every 8 moles of sulfur dioxide, okay? So those numbers, these coefficients, represent moles of our substances. They can also represent particles, okay? So if we're in particles and we're trying to find particles of one compared to particles of another, okay? This is a ratio of particles. 4 formula units of this will react with 11 molecules of this. Now notice I changed my language there. Formula units because this one is ionic, has a metal, and molecules because this is a diatomic covalent substance. Oxygen is a molecule because of that covalent bond between the oxygens, okay? This would also be formula units. This would also be molecules. So here, 4 formula units will react with 11 molecules of oxygen to create 2 formula units of iron oxide for every 8 molecules of sulfur dioxide, okay? All right, so that's basics of what you're going to need for stoichiometry. I'm going to show you a couple of problems. But one final thing I want to mention is that these numbers can also represent volume when we're talking about gases at STP, okay? So here, 11, because this is a gas, 11 liters of oxygen will react to form 8 liters of SO2 gas, okay? Now, the volume doesn't apply to our solids, so I'm not quite sure what volume of those solids. It would depend on their density and all of that. But if you have an equation of all gases, you can substitute liters for all of those numbers as well, okay? So I'm gonna go ahead and pause and make a new video to show you some simple stoichiometry problems. Then there will be a video about limiting reactants, and there will be a video about percent yield.